This chapter is entitled simply Blood, Chapter 7, Part 1, and we're over on page 632. And we notice that someone here is giving blood, which is right away gives you a clue as to what blood is looking like. And then probably one of the most commonly practiced procedures is to spin the blood in a capillary tube that is usually calibrated very carefully, and we can actually see the amounts of different constituents of the blood. So the what's called formed elements, the cellular aspect of blood, is to be found in that red zone, as well as the little tiny strip of white zone, the buffy coat it's called, right up here. Okay, so the erythrocytes, or red blood cells, are that portion of the blood then which is found in, well, this is a very high concentration of, or percentage, 45% is right up there, a pretty high level. Maybe there's a lot of steroid in the blood, like testosterone. Well-fed individuals, shall we say, because the range is generally a little bit below that on average, and certainly one is not anemic when the range is down in the 30s, like 37, 38. But I'm speaking as a 71-year-old who knew a lot of life in the 50s and 60s and 70s, in which the erythrocytes represented a slightly different percentage. But at any rate, the buffy coat here usually represents a relatively small percentage, less than 1% of whole blood. The rest of this is plasma. It's the liquid portion that represents over 50%, somewhere in the vicinity of 55%, or actually more like even 60%. So that's our constituents as an overview. And then when we look at blood, we're considering various components of blood. And as you read through your textbook here, you'll discover that blood is considered a connective tissue, although it lacks aspects of matrix that you would be expecting to find in a connective tissue. So we make blood in the bone marrow. We discovered that when we studied bones and the ends of the long bones. And so the main constituents of blood are listed actually right up here in this listing. It's very simply erythrocytes plus white blood cells called leukocytes and platelets, and then that which is dissolved or suspended to some degree. Mostly it's dissolved in the fluid portion of the blood called plasma. Okay, so we have that aspect to it. When we do that study, it's demonstrated at the top of the page, we refer to that as a hematocrit. So a hematocrit then is defined in the ways here in this text, and they define it slightly different levels for male and female. They claim healthy males can have a range that's centered somewhere around 47 plus or minus, and I would, that seems kind of viscous and sludgy to me. But there is an aspect of hematology, so subspecialties of internal medicine that look at blood. They actually inform me in my small medical group that if you were to stretch your hand like this, and of course I'm a very pale skin-colored person, but you can see the pink blood collect in the creases of, and so this person would be considered not anemic, because a dark red blood is pooling in the creases of the skin. That's a quick sort of observation. I'm probably much more in this range here, 40 to 42. This is supposedly the female range, and I've seen ranges where I was tested for 37, 38, and the newly minted docs of the time were a little concerned, and I went to my hematology professor way back in the 60s and 70s at that time, and he indicated, no, you're fine. You're a very vigorous, well-fed person, don't worry. So I take his word for it, and that's the way it's been for me. So then there's physical characteristics of the blood that you can check out. Blood is different from when it's subjected to fresh air. Once the blood has been through the, how shall I say, the circulation and on the far side of the capillaries and delivered nutrients, including blood, and picked up CO2, it's going to have a different color, really, in the venous system. And we notice that when we look at our veins, that we're seeing a color that is of a darker nature, and it's easy to pick up. And this is, it is the true color. There's not much in the way of what's going on in the veins and the naked eye here. So that is to be considered what's going on. But the deal is that as soon as blood hits the air, it turns a bright crimson red because it becomes oxygenated, and that's the color of oxygenated blood is the red color. Okay, so then we get into functions of the blood, and the blood has many functions. I've referred to it in many of our classes as Meals on Wheels. We have to feed 40 to 50 trillion cells in our bodies. And so in that sense, we're really engaged in this massive project of logistics, how to get food. And the cells, for the most part, remain, how shall I say, sequestered at home, wherever they're working. And so we have to deliver nutrients directly to the cells, and we have to cross the endothelial matrix to do that. And so that was an important aspect of our previous look at the cardiovascular diapathology paperwork. So distribution, of course, delivering oxygen is actually unique to the blood because oxygen, although it does pass through the skin, through the eyes, and directly oxygenates certain tissues that are close to the surface, for the most part we're doing oxygen distribution through the arterial blood supply. And we're also delivering nutrients that way too, so food nutrients, and then ultimately transporting waste products away from cells after they've done their metabolism. Another aspect, of course, is that we bring molecules of interest. So molecules that are working molecules like hormones. There's also molecules that are sort of on standby, right? So we discovered that renin activates angiotensinogen, a standby molecule that can be activated to angiotensin. So it's not exactly a hormone, but angiotensin in its active form kind of functions, you could say, like a hormone, since it's in the blood and it's traveling to a receptor site to do things like change the peripheral resistance and create an increased blood pressure, or activate the release of aldosterone. So there are many, how shall I say, molecules in residence in the blood, dissolved in the blood. And we'll notice that also when we get to the cascade that delivers us the opportunity to have a blood coagulation in a scab form whenever we get a cut. Okay, so there's regulation that's described here, a regulatory function. Maintaining one thing would be body temperature. So water itself has a specific gravity and carries heat with it. And so water is, you can actually warm yourself more from warm water than you can from warm air. So it delivers a lot of heat. in that regard. So we'll pick up regulation in number 2.